great, so that everything's just kind of contained into one place. Answering on Facebook is a bit messy. Discord is easier for me to read, and I've got it up here as well. So yeah, welcome guys to, I guess, the second Arduino 101, but the first live session where we're covering it. So what I've got in front of me at the moment is a Windows 10 virtual machine. Normally I'm a Linux person, but we're using the simulator this time. So if you don't have an Arduino, you're more than welcome to follow along. It's actually quite a decent simulator. It's not as feature rich as some may want, but it has got some pretty good things. It's got buttons, it's got some kind of I guess speakers. Is a what is it? Piezo buzzers. That's the one. Resistors. We got motors and servos and stuff like that. So yeah, it's pretty good, going. Yeah, and obviously it's if you don't have an Arduino, obviously this is the best thing that you can use. But in general, it's also a good debugging tool, and in general, it's nice to have something like this, because at least then that either you're interested in this sort of stuff, or you've written some code and it definitely works here, so you're going to buy some hardware to do it on. So yeah, so simulations in many respects are a really good way to go. So let's walk through the simulator very quickly. So this is what we've got. If you've downloaded it, then it will appear in a file like this, and we've got an Uno Ardu sim. This is the one that you want to select. It's not something you install, it's just kind of an application that runs automatically, so that's really good. No installation is needed as far as I can remember. And this is what it comes up with. So in this instance, we've got a int count variable, we've got some void setup and a void loop. We'll get on to what those mean in a minute. I should point out that this Arduino 101, it is a 101 series, so we will be covering mainly the basics, and we'll get into some more complex stuff later down the line, but for now it is basics. Yeah, so what you'll want to do is you can either open up your own Arduino IDE, which looks something like this. In fact, it looks pretty much like this throughout, whether you're on Windows, Mac or Linux. So you can write your code in there, save it, and then load it into here. As this is a virtual machine, that won't work. Well, it will, but it's more fiddly doing it that way. So what you can do is you can just put edit, view, and then copy and paste the code from your virtual machine onto your main machine. I should point out that if you're going to do this, then and have like an Arduino IDE on your host machine, then you need to select in your VirtualBox setup. Where's it gone? There we go. In VirtualBox here, we need to make sure that in settings, and I think system, is it? Might not be. Just where is it? Is it just general? It might be general. Yeah, so in general, go to advanced, and you need to make sure that bidirectional is selected. This allows you to copy and paste code, or copy and paste anything, from the host machine to the guest machine, and the guest machine to the host machine. So it's really quite useful. So make sure you've got that enabled, and then you'll be able to do it this way. So you can edit the code inside here if you want, or as I said, you can copy and paste. It's entirely up to you, but let's just execute this code for now. So this is the code that we've given. We're going to press compile, and we can see that it compiled successfully. Let's say we're going to write something else. Let's put an error in this. Let's put a semicolon there, and it should come up. It comes up with quite a nice error actually, so that's useful. But it does come up with errors and error support. It doesn't have any sort of IntelliSense, I don't believe. Let's just try it out. I suppose this is a kind of IntelliSense that you could use, but it doesn't have IntelliSense like you would use in Visual Studio or PyCharm or something along those lines. As soon as you do that though, then you can compile, accept, and watch these blink for quite a while, and then go up to execute and run, or F9 in this simulator. Run, and then your code will be running. Execution processing. So I assume that's all pretty much good to go. Let's just get rid of that. Cool. So, as this is an Arduino 101 series, we're going to cover the basics, as I said. So, what I'm going to do is I'm just going to get up my Arduino IDE. So, some of you may be aware of what's going on, some of you may not, some of you may not even know what an Arduino is. And if that's the case, then I recommend you have a look at the Arduino website. It's a font of really useful information, but essentially an Arduino simply is a microcontroller. Now you may be asking yourself, what's the difference? I've heard about Arduinos, I've heard about Raspberry Pis. What's the difference? When do I use one or the other? And those are really good points. For me, an Arduino is, it doesn't have an operating system, doesn't have anything. All it has is essentially lots of libraries built on each other so that you can write some nice high-level code and it will do lots of cool things. So because it doesn't have any operating system or anything like that, this is what we call a real-time device, or a microcontroller. And it's used to control things like hardware things, LEDs or motors, servos. In this case we've got buttons and speakers and things like that. So this is the sort of thing that an Arduino would control. You can imagine it as a muscle, basically. This is the muscle of your project. Pi, it has an operating system, so it's it's like any ordinary computer you've got. Your computer right now will do exactly the same thing as a Pi will do, and vice versa. The difference is the processing power of the Pi. Now, with that in mind, that means that the Pi is much more processor focused. It's much more, you give it sensor values, you give it information, it processes it, and it comes out with an output. So you may be asking, okay, so let's say I'm doing a project. Let's say my project is to build a smart home system. How would that work? Well, the Arduino would be the one controlling the motors. Things like, let's say you've got automatic blinds. Okay, the Arduino will be the thing that is controlling the motors used for opening and closing the blinds. The Raspberry Pi may be the thing that actually tells the Arduino, now it's time to open the blinds, or I want you to open the blinds now. You may have a phone somewhere, you click a button, it sends a message to the Pi, and then the Pi sends a message to the Arduino saying, I want you to do something, do it now. So, and this is what we call a master-slave relationship. So, if you've got any questions, leave them down in Discord chat. But that's the basic idea of an Arduino and the difference in between an Arduino and a Pi, because I've seen 1,000 YouTube videos try to explain basically what a Pi is and what an Arduino is and how they differ. So main thing to realize is that an Arduino is used for controlling low-level things. A Pi is used for processing things and telling an Arduino that it wants to do something. Arduino is the brain. Arduino is the muscle. Raspberry Pi is the brain. So with that kind of explanation done now, let's go over to the IDE. So in all Arduino programs, you've always got two loops, or two methods, I should say. You've got the void setup function, method, whichever we want to say. Function and method can be used interchangeably. And we've got a void loop. Okay, so as one might expect, the void setup function is used for setting up everything. It's used for setting up what pins you've got, what hardware you're using, things like that. The loop is where your code will run. It's where This is effectively a main function in a C++ script or something like that. So this is where most of your code will run, and it will run repeatedly. So this can be likened to, I guess, a while true. I can't type. I really can't type. There we go. So this and this are the same thing underneath. I mean, if you really want to be pedantic, then the void loop is that. That's all void loop actually is. It's a for loop that runs forever, or a while true loop. There's controversy as to which one is better, or which one you should be used. But effectively, a void loop, the void loop function is a while true loop. That's all it is. So I guess first things first that we should do is we should turn an LED on. Okay. Now the Arduino, this little thing, this is the Uno, by the way. There's many different types of Arduino. There's the Mega, there's the Leonardo, there's the Nano, there's the Micro. There's tons out there. This is the Uno, and it's probably the most common device that you will use in the Arduino line. So the Arduino has an inbuilt LED, okay, and it's on pin 13. Okay, so this is the inbuilt LED that the Arduino Uno has, and what we're going to do is write some code to turn this on. That's all we're going to do for now. Okay, so first things first, what I'm going to do is, remember this is not a C++ tutorial either, so if you're stuck with some of the programming concepts, let me know again down in the chat. I'm more than happy to do at possibly some point a C++ 101 thing as well, but that will take a bit more time. Yeah, so for now we're going to write a const int, and we're going to write let's say LED is equal to 13, semicolon. So you may see in some scripts they use define instead. Define and const are essentially the same thing. I think define is more a C style thing, const is more C++. Take that as you wish. Arduino is more C++ than it is C, generally speaking, although it's a bit of a butchered version of C++, so you know. So anyway, so we've got a const int LED is equal to 13. So then what we need to do, now this is just a variable, by the way, we're not actually doing anything here, we just you know, we don't want to, I mean, have a look, we've got 13 different pins that we can use. 1 and 0 are special pins that we'll get onto later. There's for transmitting and receiving information. But ordinarily you would have 2 to 13 pins. Now you don't want, you know, to say, okay, do something at pin 13, do something at pin 2, do something at pin 3, because you're not going to know what pin 2, pin 3 and pin 13 are. Of course you're not. So we want some variables for them. We want to name them. In this case, we're going to just name it LED, and that's how we're going to do it. So that's fine. But now we need to actually tell the Arduino what we want pin 13 to do. Do we want it as an input or an output? Okay. Now these are the two only things that a pin can do. It can be an output or it can be an input. Now for an LED, that's usually going to be an output, and for something like a button it will be input. Okay, but we'll get onto that in just a sec. So to define what pin, to define if a pin should be input or output, we use pin mode, like that, and we can see that the Arduino IDE has highlighted this for us, so we know, excuse me, that it is a built-in function, which is good. So then we've got pin mode LED. So this is saying at pin 13, change it to output, like so. And then, That's all we need to do there. So remember, setup is just setting up our code. It's setting up our pins. That's all it's doing. Then in the void loop, all we can do to turn the LED on, or off for that matter, we need to use something, another built-in function of the Arduino library called digital write. Okay, and it looks something like this. Digital write with the W capitalized, and then we can just put LED high. End it with a semicolon, and then we can just verify it to make sure that it's fine, which it should be. There we go. Now I'm just going to copy and paste this code into here. I mean, I wouldn't really need to. You can just write it all in here, but we'll do this just like that. So compile, successfully, which is good stuff. And now we're going to go to execute and run. And as you can see, we have indeed turned pin 13 on, which is great. Awesome stuff. So I'm going to do it actually in here now, just because it's going to be easier to alter code quickly. So we've got pin 13, but as I said, pin 13 is a built-in LED. So what we don't actually need to use this. We don't need to say LED and define it as an integer, because the Arduino IDE already has a built-in function for this, and it's called, as far as I'm aware, built-in, I think. I'm just going to check that actually because I can't remember. Come on. I think it's built in, but I might be wrong. So I'm just checking. Is it built in? LED built in. I knew it looked a little different. LED built in. And we'll need to do the same thing down there. So we've got LED built in. We've set it to output. We're setting it to high. So in theory, this should be exactly the same, or do exactly the same thing. We'll run it, and indeed we turn the LED on. Now this is because, as I said, it's a built-in, it's a built-in LED, and the Arduino IDE allows us to use it. But obviously, pin 13, it's still a pin. It's still something that we can change. So although it's a built-in, although it's mapped as such to the LED, of course we can change it. We can put a wire in there and put it to a different LED. We can put it to a 7-segment LED or a button or something like that. Of course we can. This is just a nice little thing that most microcontroller or most libraries and things will have. So now we've got it turning on, which is great. What we're going to do is now make it blink. Now this is the hello world of electronics and embedded systems. So let's try to do that. Let's write it. Well, if we've turned the LED on, we need to turn it off, don't we? LED underscore built in, and set it to low. Semicolon. Compile, accept, and now let's run it and see what happens. Okay, so this is interesting. This kind of brings in a really good point about microcontrollers. As you can see, although it looks like it's off, it's actually on and off. Or I'm not meaning that it's in a quantum state. Instead, what's happening is that the Arduino. Remember, this is just so this is just a while true loop, and actually you can see down here that the simulator has kindly put in what is essentially the while true loop and then the loop here. But yeah, this is just a while true loop. So although it's turning on, and turning off, it's doing it at such a fast rate that it's imperceivable to the human eye. So what this means is that we actually need to slow it down, because although it doesn't look like it's doing anything, it is. It's just doing it so fast that we can't tell it's doing anything. So we need to change this. We need to delay it by a certain amount. But how long do we delay it for? Well, let's try a delay of, let's say, 1 second. Now, in the Arduino library, it's in milliseconds. So 1000 milliseconds is equal to 1 second. So if we compile, accept, and we run, oh no, I've done something wrong. So parse error delay 1000, can I parse multiple line exception begin here? Missing semicolon, there we go. So that was the error, so let's solve that. Semicolon, compile, compiled successfully, and now let's run it. Okay, so this is a little weird now, because it's on, but it's not turning off, although we have got a delay in here. So let's have a think. It's turning on, then it's delayed for a second. So that means that the execution has stopped for 1 second. So remember in our Python code where it will sequentially go line by line, it would go here, then here, then here, then and then so forth. What's happening is that the Arduino is going to here, the execution is there, then it's here for 1 second. So it stops there, and then it continues, and it goes back up. And remember, this is while true, so although we've got the end curly bracket there, we go back up to here. So what's actually going on is it's turning on for 1 second, then instantly turning off, and then turning back on again. So you may have guessed it, we need another delay. Let's go to File, Edit, and we need to put a I can't type in an audience. Delay of 1 second. And now we will run it, and lo and behold, we have a blinking LED on pin 13. Fantastic. So this has used the digital write delay, and that's pretty much it for now, actually. So now we've got this working, which is good. Let's have a think. Have we got more LEDs we can use in this? Oh, we do. Good stuff. Righty then, I might just have to have a quick look at how to do these. Let's say 2 and 3, and let's see what happens. So what I'm going to do is I'm going to try and turn these LEDs on as well. So I'll map them to pin 5 and pin 4. And so if we're adding some more LEDs, then what do we need to do? Well, we need to go back to our pin mode, and we need to tell the Arduino what these pins are. Are they inputs or are they outputs? Well, we need pin mode, and we're addressing pin 4. Although now we can actually make use of our LED variable, so we can change that to 4, and we can create a new const int LED2 is equal to 5 semicolon, and now we can say LED output and pin mode LED2 set to output semicolon. Good stuff. And what we can try to do now is we can change what we're turning on. So let's change it to LED. And let's see what happens. Compile, accept, and run. Okay, cool. So it looks like LED2. What was LED2? LED2 was pin 5. Pin 5 is on. Okay. Not 100% sure why that's actually on. Oh, can I change the colour of it as well? That would be cool. Oh, I can. That's cool. Sorry. So it's possible that this one's turned on. Why is that actually turned on? I'll set the output. Okay, it might just be that it's automatically set to high, which is no worry. We can sort this out. So what we can do is to make sure all of our LEDs start low, as in they're off. And something to point out, I believe. So digital right, these low and high things, keywords, these are actually variables as well. Then they stand for 0 and 1, because as we all know, computers work in zeros and ones, 0 being an output usually, and 1 being an input usually. And in this case, 0 is in fact low, so it's down, and 1 is high, meaning that it is, we're providing power to it. So these are variables in their own right as well. But we can use high and low because the Arduino library provides them for us. What we can do to make sure all of our LEDs are turned off or turned on, we can actually put our digital write code inside the void loop, the void setup stuff. So what we can do now, this will only run once, but if you have a piece of code or a project whereby it starts up and it has to start up at a particular state, then this is a really good way of doing it, because it's set up, this is all of our setup code. This is done before our loop actually begins. So this is done before loop. So this is a good way of setting up everything, including giving states to our components. So we're using digital write LED, and we're going to set it to low. We're going to create another digital write and set LED 2 to low, and we're going to use digital write again. Let me know again in the comments if the audio is coming out okay. Hopefully it is, but you never know with these things. LED built in. I'm going to set this to low as well. So this is going to set all of our LEDs to low, and we will compile, accept, run it, and there we go. So so digital pin 5, which was LED 2, is now turned off. So previously it was turned on. That's because we didn't actually say to do any. Okay, good stuff. We didn't actually say for it to do anything. You can imagine it as it just gives it a random state. So because we've started our code with setting all of our LEDs to low, we can now say for absolute certainty that as soon as we go into the loop, we know that everything is off, and as soon as it turns on, that's the stuff inside our void loop function. So that's cool. So as an exercise that you can, I guess, do now or do later or whatever, is write a blinking program which I guess goes from pin 13 and then pin 4 blinks, and then pin 5 blinks, and then it goes back to pin 13 blinks. So 13 blink, 4 blink, 5 blink, or 5 blink, or 4, 5, 13, something like that. That could be a bit of an exercise for you to test how that's going. So, righty. Also have a play around with these delay variables as well. So get one LED to flash faster, get one LED to flash every 2 seconds or something like that. So have a play around with that and see what you think. For now, we're going to get off LEDs. Well, we're going to stay on, but we're actually going to look at another type of component, and this one is going to use a button. So, how are we going to use these buttons? Well, as always, we need to first assign it a pin value. So we've got pin 4, we've got pin 5, and we've got pin 13. Let's now use pin 6. Why not? Okey-doke. Are we allowed to? Yeah, there we go. So this might take trial and error because I think I know what these mean, but I just want to but I might need to just check. Anyway, so we've set the button to 6, and as you can see, pin 6 has lit up as a input, and it's got a value of 1. So what we need to do is we need to go into our code, and we need to say, well, we need to say const int button, or btn, is equal to 6, was it? Yes, 6. Yeah. The block wasn't on. 6. There we go. Cool. Now we need another pin mode. Now let's have a think. LEDs were output. So what is a button going to be? A button is going to be input. So we write btn input. And we actually, I think I do know what that means. Well, we'll be fine. So let's get rid of that. So, what do I want this button to do? I think when the button is pressed, we want the LED to turn on, and when the button is down or off, we want the LED to turn off. Simple as that. So how are we going to do this? Well, in a button, or in any sort of, when we're using input as a function, or a keyword, we can't use digital write, because digital write almost sends, you can see this, you can imagine it as write will send 5 volts to a component, doesn't send 5 volts, but it will send an amount to a component, and it will light up. That's how digital write works. It sends something out, it sends some current out to the component, and a component lights up or does something, or it spins or whatever. Well, input doesn't do that. Input takes something in. It takes a value in. So similar to our Python code, where we printed out something, we wrote that out, we used input to provide user input for us. So a user would provide the name, address, or whatever, and we would use the input function for that. It would be something like a is equal to input blah. So the same sort of thing is here. We need to input something. We need to read something. We need to read the value, and it just so happens that the Arduino library has something called that. It's called digital read. So first of all, we'll need to create a simple variable for this to store the input value. So we can say that it's going to be, I guess it could be a boolean or an integer. I'll use an int for this one, so int button state, or btn state, however you want, and we're just going to say it to 0. Now, a quick note: if you use const here, it will most likely, if the compiler is decent enough, it will tell you you can't do that as soon as we write a piece of code on it. And the reason for that is const means that the value here in this variable will not change, whatever happens. BTM will always have a value of 6. LED2 will always have a value of 5. So that's what const means. Because we want this button state to change, you know, we can't have const here. So that's why we can't have const there. We can only give it the type, and our type is integer. So what we're going to do is we are going to say button state is equal to, now we want to read in the input from the button. So how do we do that? We use digital read, and that will we need to tell it what to read. What it reads is button, like so. So as soon as we've got that, this will provide the state of, well, if we press the button, then it will provide something. Depends on this. It might provide a 0 if we press it, and 1 if we don't press it. If it's the other way, if it's this one, then it will be the other way. Either way, it will provide a value when we press it or when we don't press it. And we can do something with that value. And in fact, has this got a serial monitor? That would be really useful. This has got a, no, I want to keep this code through them. If this has got a serial monitor, that could be really useful. Let's just copy that code just to be sure. Yeah, whatever. Has this got a serial monitor? Oh, it does! Oh, this gets better and better. Right. I don't know if this is going to work, but we might try something. Okay, so open it up. Actually, we'll do it later. So, we've got button state. Now, as I said, this button state will be a 1 or a 0, depending on whether we have the button pressed or not. Now, we can do something with that state. If the button is pressed, we can say that we want to turn the LED on. If it's not, then we want the LED to turn off. So how do we, think back to Python, how did we do that? How did we make a condition whereby if something was true, then you did something, if else, it was something else? Well, I've already said it, we use an if statement. So we can say if, how do you do an if statement? C++. Button state is equal to, and we can simply put high for this. Button state is high, then no automatic indentation, I guess. Then we can say digital write, and we can say LED, and let's set it to high. Else we can say oh, I guess we could actually just put else. Digital write LED low, like so. Bracket. There we go. That looks ish. Okay. And let's compile it and accept and see what happens. I'm actually not sure of what the output's going to be. It's going to be dependent. So we're going to run it. And what pin did we use? It was LED, wasn't it? LED, which was pin 4. LED was pin 4. Okay, so we're on. So what happens if we press the button? It turns off. Yes. Right. So, oh, let's switch it. Yes. This is cool. Oh, I love the simulator. Right. Oh, it's getting interesting. So, what you can see here are the digital waveforms, and what this is saying is that it starts high and goes low, or it starts low and goes high. So, in this instance, the state of the button is going to be 1 when it is the state of the button is going to be 1 when the button is off, when you've taken your finger off the button. When you haven't got it pressed, it's going to be 1 or high. And when you press the button down, then the state of it is going to be 0 or low. But let's say we want to change that. we want to change it so that the state of the button is going to be low to start with, and then as soon as you press it, it turns to high. Now, why you would do this, that's going to be a topic for another video, I think, but it's to do with using what's called input pull-up and input, whatever the inverse of that is, can't remember. So inverse pull-up and inverse pull-down, I think, and that's to do with how you arrange your resistors and things. It's used for, actually we'll get into it in a different video because it's beyond the scope of this video for now. But this is really cool because what we've done, although it doesn't seem like, you know, we've done much, we've just used a button and we've used an LED. Digital write is used to send a voltage to a component. Now this can be any component. This could be a motor, this could be an LED, this could be, I don't know, this could be absolutely anything. Digital read reads an input. Now again, this could be, you know, it could be a button, it could be, you could be reading values from anything. I mean, I guess you could use it for a potentiometer, although you really shouldn't at all, but it's possible. Now we'll get on to why it's and it's to do with this part, the digital part. Now remember, digital has two things it can be. It can be either on or it can be off. With a potentiometer, which we'll get into in a future video, I think actually this might have it. But anyway, with a potentiometer, that is analog, meaning it scales. It has more than two states. It can go from 0 to 1024, I think, is the highest it can be. Obviously, that could be mapped to a different value if you want. But yeah, so digital write can be used for mostly anything. Digital read can be used for mostly anything, and that's what's great about it. Because although we're only using two components here, these two terms, these are really powerful terms because they allow us to control pretty much anything you'll see, not just on this simulator, but in the real world. You know, you'll be using these terms constantly, and that's really, really good. So we've now got a button turning an LED on and off, which is great. What now? Let's have a think. What time is it actually? Okay, so we're getting close to the finishing point. I think for now, because I think actually what I'll do, because this could be quite interesting, I'll bring up what's a really, really good debugging tool that you would normally have in the Arduino IDE, or you would normally use in the Arduino IDE for debugging. This is actually quite sophisticated because we can see the digital waveforms as well. So if we, how do we look at these? Oh, I think, yeah, there we go. So we can actually see the waveforms change here. So if you change it to the button, where's the button? That was pin 6, was it? I think so. Input, yeah. So this is the digital waveform that's actually going on. Now as soon as we start to run this, execute, run, does this change? There we go. So now we can actually see, this is so cool, we can see the digital waveform change as soon as we press this button. So as you can see, it's low, goes to high, back to low, high, low, high, low, high, low. Oh, this is so cool. So that's really, really cool. So, and as a point, as I said, digital only has two values. It only has 0 and 1, high or low, or low and high. An analog wouldn't look like that. An analog would be spiky, very, very different to that, and it would be slightly, it wouldn't have this square wave that you see. It wouldn't have this. It would be, you know, spiky and down here and up there. It would look more like a sine wave oscillator than anything else, which is actually how analog synthesizers work, if you're interested in that sort of thing. I am. I like synthesizers. Anyway, so we've looked quickly at the buttons. I think a challenge. Oh well. So although this works, yes. Actually, I have another thing we can do. So this could be an extended exercise, as there's only 10 minutes left, and it's been mainly me going, oh, I like this. So the extended exercise would be two things, or you can have a choice actually. The first one, well, three actually. If third is optional. So the first one is a traffic light system. So the first, obviously, the first one was going from 13. Sorry, it would be turning LED 4 on, then turning LED 5 on a few seconds later, then turning LED 13 on. Okay. Now these can change colour. These can be RGB, RYGB. Sorry. So this can simulate a simple traffic light. Now we've got a button as well, and this works. So what we can do is we can simulate a proper traffic light system. So press a button and it starts our LEDs. So LEDs remain, well, LED 13 and LED 5 remain off. Okay, LED 4 remains on. That is our green light, let's say. Then as soon as you press the button, let's say it waits for a second and then it changes to LED 5. Now, Now a traffic light system doesn't go red, yellow, green. It's something like red, red, yellow, green, or green, yellow, red, or something like that. So what I want you to do is simulate that procedure. I don't want to see 4 go on, 5 go on, 6 go on. I want to see 4 go on, 4, 5 go on, 4, 5, and then, sorry, 13 go on, for example. That's what I want to see. So simulate a traffic light system. That would be quite cool. Second thing that I think would be quite interesting is, second thing is we can press this button and it turns our LED on. But what happens if we want, so let's say you're going in a bathroom and you've got that pull cord, you pull it down and the light remains on. You pull it again, the light turns off. I want to see a similar system here. I want to turn it on and turn it off. So I want to see that as well. Now a final challenge, and this is only for the people that have Arduinos on their person. I want you to create a circuit that simulates exactly what is going on here. You can use the same pins. We can use pin 4, pin 5 and pin 13, or if you've got your own LED, you know, change it to pin 7. I think that pin 7 is not in use. Change it to pin 7. So yeah, that's what I want you to go away and try your best with. Now I will say, to help out a bit with the turn on, pull down cord, turn off, pull down cord thing, is that we've got the state of the button. Now that's fine, but the issue we've got is if the button state is high, then the LED turns on. If the button state is low, then the LED turns off. Now we don't want this procedure. What we want is the LED to be high. It is the button to be high, and when you pull the cord, light turns on. So that means that you pull the cord, your button state will be high, light turns on. Now you release your cord, the button state is now low, but the LED remains high. It remains on. So how are we going to do this? Well, there's a few ways of doing this. Well, probably one decent way of doing this. The best way to do it is to take your button state and create a previous button state as well. So keep this as the current button state, but also have a previous button state. So you can say, I turn it on. You turn on, and the previous button state will be something like 0, and then you can say if the button state, this is rather more for the circuits sort of thing than the simulator, but for the circuits, what you'll need is to turn it on. You'll need a current state and previous state. The previous state will hold the previous state, and if the current state is not equal, I think, to the previous state, then I want you to do something. So I'll do that next video, because it's more easy to show you what's going on, because it's a bit of it takes a minute to get your head around. What I actually want you to do for now, though, is, and something that it's a bit of a hint, is instead of just reading the state of the button, I want you to also read the state of the LED. That's the really important part, and of course we can read the state of an LED. So let's just quickly see if we can use Serial Monitor, because this is going to be a really good debugging tool if we can get it to work. So let's go File and Edit. So to use the Serial Monitor, we need to include a library. Now in C++, we do #include. Actually, do we? I can't remember. My brain's gone blank. I don't think we do. I think Serial is a built-in Arduino function. Is Serial a built-in Arduino function? It is. Okay. We don't need to do that. Brain went blank for a minute. Now, instead, we go into our void setup and we type serial.begin. And now we need to set what's called the baud rate. Baud rate, I believe, is kind of a communication speed as such. And we're going to set it to 9600. Serial.begin 9600. 9600 is the baud rate. Then down here we're going to say serial.write. It might be print, I can't remember. It's print line. Keep getting these terms mixed up. Serial.println, there we go. And we're going to input, or the input for this is going to be button state, semicolon. Like so. And we will compile this, accept, and let's see if this works. That'd be cool if it does. Run. Oh, it does. Goody. So this is going to be quite useful. So this is what you would actually be using on the Arduino simulator, because you don't get all of these fancy goodies like the digital waveform simulator. Instead, you will get just these. And as you can see, if we press this down once, we can see that it changes to the 1, back to 0, 1, back to 0. But this is what I was getting at regarding the previous previous button state and the normal button state. We don't want all of these trailing zeros and trailing ones. What we want is just one. We just want one signal. We want an on. We want an off. That's all we want. We don't want 5,000 output statements and then one input statement. And it doesn't matter where we actually put this code. We can put it. So we can put it there, compile, accept, run, and serial monitor. So we run it, it comes up with 1, which is fine, but we've still got 5,000 different 1s. What I want to see is 1, 0 and 1, 1. And to do that, you'll need to use what I said, the current state and previous state functions, or not functions, but you'll need to define them. So those are the tasks. Traffic light system, turn LED 4 on, LED 5 on, LED 13 on, or LED 6 on, whichever. Change these so it's just 1 0 and then 1 1 instead of having a million different 1s. And the final one is a bathroom light pull cord system, whereby pull it once, LED turns on, pull it once, LED turns off. So those are the tasks I want you to do. Feel free to take this code and run it in your own simulators. Take the code, run it on your Arduino, and I encourage you that if you've got an Arduino, then get it out and start build what is build the circuit that will use this, or build the circuit that has a button, has an LED and things like that inside as well. Hopefully the next video I'll have a circuit diagram of the completed circuit for this video. I'll also have a circuit diagram for actually it doesn't matter. So those are things that I want you to do. As I said, I'll do a circuit diagram so you can see it for next video. I'll also go through the tasks next video as well. Okay, sorry. So the simulator is Uno Ardu Sim. It's a catchy title, I know. I have done if you go to the YouTube channel, Arduino Raw Robotics Society, obviously, like, comment, subscribe. Go to the Arduino 101 playlist. The first video is me installing the Arduino IDE, which is this tool, which is this. So it's me installing this for, I think, only Linux distributions this time, because it's basically the same for Windows. I also go through how to install this simulator as well, but as I said, it's there's quick guides and help guides as well. Just download the. I can't remember if I put this on the on a Google Drive, but this is just downloaded from the internet somewhere. I think if you just go into your favourite browser, Edge is by far no means my favourite browser, but I haven't installed anything on this virtual machine because I have to run everything else. What is it? Uno Ardu Sim. There we go, that'll do. Simulator download. This is it, from Queen's University. Go down and it will be, I can't remember what version this one is, 2.8.1, so it's this one. So download this, you'll get a zip file, unpack it, you'll get this, and then double click Uno Ardu Sim. It's not an installation, it's not an installer, so you don't need to go through any of that. Instead, it's just this, it's just this program. So yeah, have a play around with the sim, and yeah, that's it for this video and stream and everything. That's all that stuff. So yeah, have fun and catch you later. No, wrong one. Where's OBS gone? Oh, there it is.